In this video, we're going to talk about precipitation reactions. What this means is you have at least two solutions, so two or more solutions, and remember solutions are aqueous. They react to form a solid. So in this case, solutions, what that means is it's just something dissolved into a solvent. So we say it is soluble, it is something dissolved in something else. On the other hand, the solid on the right-hand side, we say that is insoluble. It cannot dissolve into that solution, so it forms a solid. In this case, we call that solid a precipitate. We can also say that whatever that solid is, it will precipitate out of that reaction. So in this case, that word precipitate, it is both the noun of what it's forming that precipitate, and it is a verb because it can precipitate out of a reaction. So here's a simple example. We have two of these just free ions in solution. So we have silver, and again it's in solution, so it's aqueous. And we have chloride, again in solution, so it's aqueous. Remember that silver will be your cation and chloride will be your anion. And they react to form AgCl. So notice right here I put that it is solid when I was talking about the state. So how did I know that? Right here, you have the same references in your own reference sheet. This is a solubility chart. So what this tells us is it tells us what is insoluble and what is soluble. So on the top, notice that we look by the anion. So chloride, for example, it says that these are soluble. Compounds containing chloride are soluble, except when combined with silver, lead, or mercury. So in this case, it's combined with silver. So that tells us it is insoluble, so it will form that solid. We could say that that silver chloride is the precipitate, or we could say that silver chloride will precipitate out of the reaction. So let's move on to one that's a little bit more complex. In this one, we have silver nitrate, AgNO3, and we say that it is aqueous because nitrate is soluble all the time. There are no exceptions. So silver nitrate, which is aqueous, reacts with sodium bromide. And again, bromine is always soluble except for these three exceptions. Since it is not one of those exceptions, we say it is aqueous or it is soluble. And they react to form AgBr. And again, bromine and compounds with silver are insoluble. So we put our solid right here. And then NaNO3. Remember, all of our nitrates are soluble. And you will have this chart to use on every quiz or test that we take. So notice how we got this. It was a type of double replacement reaction. So your cation right here, this silver, will attach to the bromide, that anion on the other. And then your sodium, which is the cation here, will attach to the nitrate, which is your anion here. So notice that we say the precipitate is AgBr or silver bromide. We could also say that silver bromide will precipitate out of the solution. Let's look at another example. We have sodium sulfate, and I went ahead and reminded us up here that remember that sulfate has a -2 charge, or a 2- charge. So when we look for sulfate on this table, sulfate is right here at the bottom. It is soluble except with these 4 exceptions. And again, to see a bigger one, go ahead and look at your reference sheet that you have. This does not fit the exceptions, so we know this is soluble. And then we have potassium chloride. Chloride is soluble except with these exceptions. This is not part of these exceptions, so this is also aqueous since it is soluble. So remember, this is a double replacement. Our sodium will go with the chloride, and we look up here. Chloride is soluble except for these exceptions. That is not one of the exceptions, so this is soluble or aqueous. And your potassium will go with that sulfate. Remember that sulfate has a -2 charge. So K2SO4, and sulfate is soluble except with these exceptions, which this is not a part of these exceptions. So this one is also aqueous. So notice with this chemical reaction, They are all aqueous. So what we see here is we are not producing a solid. So it does not fit that precipitation reaction that we know. So this is not a precipitation reaction. If you were to see something like this, what you can write is no RXN. What that means is there is no reaction.